So one way to climate-proof water infrastructure, which is the focus of this webinar, is ecosystem-based adaptation. And so that's really about harnessing the power of nature and integrating that into water infrastructure cycles. So this is this Convention on Biological Diversity's definition of EBA. It's the use of biodiversity and ecosystem services as part of an overall adaptation strategy to help people adapt to the adverse effects of climate change. Some of you may be more familiar with the term nature-based solutions for climate change, which is also commonly used. So with the water infrastructure examples that I very quickly rolled through previously, we were really talking about one type of infrastructure, and that's gray water infrastructure. So water infrastructure can exist along a continuum from gray to hybrid to green solutions, or what are sometimes referred to as natural infrastructure assets. But ecosystem-based adaptation is really about paying more attention to the rest of the continuum than has been traditionally done in the past. So moving gray infrastructure projects towards hybrid or even green solutions where it makes sense to do so. And that might be applicable to either existing infrastructure, or it might be integrated into the development of new infrastructure projects. So this flow diagram that I've got up right now, the text may be hard to read depending on some of your screen setups, but that's okay. The main point of this slide is to show how different types of ecosystem-based adaptation in the action column can be applied to water infrastructure to support long-term provision of infrastructure services like flood management, water supply, erosion control, hydropower production, and others. So importantly, one of the nice things about ecosystem-based adaptation is that they can do all this, supporting the infrastructure, while also providing additional services or co-benefits, as they're commonly called, that gray water infrastructure doesn't provide on its own. So in the action column, you'll see that I've used a couple of terms: protect, replace, assist, accompany. I'm going to go through each of these so I can explain the different types of ecosystem-based adaptation. And so the first type of EBA directly protects a hard gray infrastructure project from climate hazards. And in doing that, it can increase its lifespan. It can reduce operating and maintenance costs. An example of a protecting type of EBA would, you can think about embankments or remeandering rivers that retain sediment upstream of a dam, thereby extending its lifespan. The second type completely replaces the need for gray infrastructure. So you can think of wetlands, for example, that if they were restored, maybe retain enough water during floods that gray infrastructure is no longer needed downstream. The third type doesn't protect or replace gray infrastructure, but it assists it by amplifying its service provision. So you can think of a restored wetland in combination with a dam, for example, that both provide flood management services. And then the final type is an interesting one because it doesn't really benefit the gray infrastructure at all, but it accompanies it as an add-on to a project. And so we're thinking about water infrastructure project cycles here. And because we're thinking at that project level, one of the things that can be done is that ecosystem-based adaptations could be implemented as part of a project to provide co-benefits that increase a community's overall adaptive capacity to climate hazards, even though it's not really doing anything with respect to the focal services. You might think about riparian planting to provide green space. And so there are several examples of ecosystem-based adaptations. I'm not going to spend a lot of time showing you these pretty pictures that I have in my slide deck, because I know Matisse is going to, he's got several more in store for you, and we'll go into more detail about some specifics. But I will roll through a few examples just to get you oriented. And so river remeandering is one option. The creation of side channels is another. Floodplain widening, green embankments, riparian planting, forest restoration, land use management, wetland restoration. So those are all examples of different ecosystem-based adaptations that could be harnessed to assist water infrastructure. So that's great. So now we've got a way of thinking about ecosystem-based adaptation with respect to water infrastructure specifically. But what about operationalizing it and taking it to the actual project level? So some of the work that ESA has been doing with GIZ is looking at exactly that by articulating EBA insertion points within a water infrastructure project cycle. So what I have up on the screen right now is an example of a standard project cycle, although we've placed it within an adaptive cycle. So you've got the adaptive plan, do, learn cycle happening around the outside, and then in the inner circle there are the typical stages that most infrastructure project cycles will go through. So problem definition, development of project alternatives, then selection of projects, mobilizing the resources in order to be able to do the project, actually building it, then operating it and maintaining it, and importantly, in the context of climate change adaptation, monitoring the effectiveness of the project and, evaluating and adjusting based on the results of that monitoring. So where does EBA fit into these different components of a project cycle? Well, there's a few things that we've identified in the work with GIZ that are different, and they're unique considerations for ecosystem-based adaptation that are things that traditionally people that are engaged in water infrastructure projects don't always have to think about. And so with EBA, you might be doing something like wanting to include a wetland upstream of a dam that will provide additional flood protection benefits or stop some sediment from filling up the reservoir too quickly. And suddenly that introduces new spatial scope to the project. Some ecosystem-based adaptations might be seasonal in their benefits, and so that could affect the temporal scope of the project. And of course, when you're extending the spatial scope, suddenly you might be looking at things like new jurisdictions, could be different countries, could be different states, could be different municipal areas, but also different affected groups. And so this affects how you structure the participation that is necessary in order to develop the project. So when we get into the project alternatives, developing project alternatives and selecting projects, there's a few different steps, like developing a natural asset inventory so that you know what the options are that are available in terms of ecosystem-based adaptation. But important one is also cost-benefit analysis. And so a lot of these additional unique features of EBA sound more complicated and expensive. And so that's one of the reasons why it's important to consider things like the co-benefits that ecosystem-based adaptation can offer when cost-benefit analyses are being conducted. And when you start thinking about co-benefits, monetizing the value of those co-benefits is a bit different than it would be for traditional infrastructure projects, because you're starting to need to utilize different economic valuation methods to get at some non-market values that might be represented by ecosystem-based adaptation alternatives. Also, as a standard part of a project cycle, or an infrastructure project cycle, there's usually a project level risk assessment With the introduction of EBA, you suddenly are thinking about new types of risk, and you're also looking at what are the risks to the ecosystem-based adaptation or the natural asset, but also how does the introduction of that natural asset affect how you perceive or identify risk thresholds for the actual infrastructure that is the target beneficiary. Also, developing indicators of risk is much more complex when you introduce ecosystems and natural assets, and likely also requires additional sensitivity analyses in any modeling that's being conducted to compare the costs and pros and cons of different alternatives. During the construction stage, if you're doing things like adding sandbars to remeander rivers or gravel to remeander rivers, for example, you might be working with different materials. Riparian planting is another example, and different activities. And these things might require personnel with different sets of expertise than are typically utilized during standard infrastructure projects. And during the operation and maintenance stage, ecosystem-based adaptation or natural assets might have different deterioration rates and lifespans compared to things like dams. And finally, in the monitoring step, there's several complexities. So monitoring is all about developing indicators, but this is hard to do when you're dealing with natural systems that have complex long-term changes with multiple systems drivers. Sometimes it can be really hard to define causal pathways, and every site's different. So you might have unique indicators at every different site. There's no real consistent way to have a similar set of indicators across multiple projects. And then you might be dealing with longer time horizons to observe ecosystem-based adaptation benefits. One of the great advantages of EBA is that it can rely on the free benefits of nature for maintenance and operations over time, but those benefits aren't necessarily realized right away when a project is constructed or completed. It might take time. You might need to dredge a side channel multiple times over many years before it actually is at a level where it's providing a full set of benefits and self-maintaining. And then lastly, there's a whole portfolio of ecosystem services, obviously, that need indicators to be tracked. And so it adds this level of complexity. Thankfully, GIZ and partners have developed a library of EBA guidance documents, and these are quite useful. I've found them quite useful myself on the project that we've been working on, that give a lot of information about how to do monitoring and evaluation and climate risk assessment and cost-benefit analysis for ecosystem-based adaptation. So these are all resources available from GIZ. And that is it for my part of the presentation. Thank you. I think